Welcome everyone. We are discussing permutation. Through this video, I will discuss permutation of things with repetition. In theorem 1, we have discussed permutation of n things taking r at a time equals to n pair when repetition is not allowed. But here repetition is allowed. So number of permutation of n things taking r at a time when each thing may be repeated up to r number of times equals to n to the power r. So here only difference is each thing may be repeated. So same type of proof. Suppose there are 1, 2, 3 n different things. N different things. And suppose there are r gaps. 1, 2 r gaps. So first gap can be filled by n ways because we can take any one of n things. Now second gap can be filled by n ways. In case of without repetition, it was n minus 1. But here it is n because we can use the thing already used for filling first gap. So repetition is allowed. That is why second gap can be filled in n ways. So third gap can be filled by n ways. Rth gap can be filled by n ways. So by FPC, fundamental principle of counting, total number of possible arrangements or permutation n into n n. How many n? Rn 1, 2, 3 r times. So this is n to the power r. This is n into n. This is n. How many n? R number of n's. That is why n to the power r. So proof is very simple. So n to the power r. Now application. One marks application. How many 3-digit number can be formed by using 1, 2, 3, 4, 5. So 5 numbers. So first gap, 3 digits. So 1, 2, 3. Unit, 10, 100. So 100 place can be filled by 5 ways. 1 or 2 or 3 or 5. So 10th place can be filled by 5 ways. Look, in case of without repetition, it will be 4. So unit place can be filled by 5 ways. So by FPC, number of possible arrangements, possible ways, 5 into 5 into 5, 5 to the power 3. So we have already solved this problem using fundamental theorem. So what is the rule? You look, using formula, 3-digit number and numbers are 5. So 5, this, it is base, number of digits, so this is base, and number of gaps, so this is at the power, 5 to the power 3, n to the power r. You remember, n to the power r. N equals to number of digit, r equals to number of gaps. So it is using fundamental, so proof is using fundamental. And look, if you use shortcut, how many digits? 5. How many gaps? 3. So 5 to the power 3. So power, at the power, this is number of gaps. Mind it, here, if 0 is used, then it will be different. I will discuss it later. Now we consider one problem. How many 3-digit numbers can be formed by using the digits 2, 3, 6, 8? 0, 2, 3, 6, 8. We have already discussed it. This type of problem by using fundamental FPC, fundamental principle of counting, in part 1. In part 1. This is part 4. So look, number of digits and 3 digits number. 3 digits number. So number of digits. Number of digit. 2, 3, 6, 8. Number of gap. 3. 3-digit number, so number of gap. Number of gaps 3, number of digits 1, number of gap. Number of digit 4 and number of gaps 3. So 3-digit number equals to number of digits 4. So this is 4 to the power 3. N to the power r. N হচ্ছে number of digits. So 4 number of gaps will be at the power. So it is 4 to the power 3. So now second one. Number of digits. Number of digits 0, 2, 3, 6, 8. So number of gap is 3. So 3-digit numbers. 3 digits numbers equals to number of gap is 3 and number of digits is 5. So 5 to the power 3. 5 to the power 3. Now look, out of these cases, there are some cases when 0 occupies first place. So they are not of 3 significant digit number. So we have to delete these numbers. These number means number which starts with 0. So if the number starts with 0, number of gaps 2. Number of gaps 2. So minus gap is 2. So it is at power. And number of digit is 5. So 5 to the power 2. Why number of digit is 5? Because in unit, because other than 100 place, here 0 can be placed. Repetition is used. That is why 5 to the power 3 minus 5 square equals to 100. Equals to 100. So look, if 0 is used, then look, 5 to the power 3, 5 digit, number of gaps 3. If it starts with 0, then they are not of 3 significant digits number. Taking 0 at first place, 2 gaps, so 5 digits, 5 square. And it will be simple if you use fundamental theorem. This place can be filled by 4 ways other than 0. This is 100. 10th place can be 5 ways and unit place can be filled by 5. So 4 into 5 into 5, so 100. We have already discussed it, but it is using formula. So if 0 occurs, then if 0 is at first place, they are not of 3 significant digit number. You have to remember this one. You have to subtract those cases. Now we consider one more problem. How many numbers lying between 3000 to 4000 can be formed with the digits 0, 1, 2, 3, 4? 0, 1, 2, 3, 4. 3000 to 4000. Look. So how many gaps? 4 gaps. 4 gaps. So 1000 place must be occupied by 3. 1000 place must be occupied by 3. So since number form are between 3000 to 4000, the 1000 place, this is 1000 place must be filled by must be occupied by or filled by must be occupied by 3. The remaining 3 places can be filled by 5 digits 0, 1, 2, 3, 4, because here 0 can be put in 5 to the power 3 ways. So 1 to 5 ways. 1 to 5 ways. Between 3000 to 4000. How many? 1 to 5 ways. Remember it, here 3000 is included. 3000 is included. 3000 is included. 3000. Out of 1 to 5, 3000 is included. If you subtract 3000, the number will be 1 to 4. If you delete 3000, the number will be 1 to 4. If it is between 3000 is, so numbers in between 3000 to 4000 is 1 to 5 minus 1. So 1 to 4. 1 to 4. So you 1000 place must be filled by 3. So 0 cannot be filled by 1000. 1000 place cannot be filled by 0. So 3 gaps, and how many? 5. 5 to the power 3. Now, next problem, number 4. In how many ways n prizes be given to R boys when a boy can receive any number of prizes? Repetition is allowed. So, a boy can receive any number of prizes. So, number of ways in which a boy can receive any number of prize. So I have already discussed it is R boys. So first prize can be given to n ways, second n, third n, rth n. So n to the power r. N to the power r. Number of prizes, this is base. Number of persons r. So n to the power r. So this is number 1. And number 2, no boy can receive all prizes. So all prizes equals to n to the power r. But here no boy can receive all prizes. So n to the power r minus r, because there are r boys. So n to the power r is without any restriction. But here no boy can receive all the prizes. So number of ways in which no boy can receive all the prizes equals to total number of prizes minus number of persons. So n to the power r minus r. So you can put suitable values of n and r. This is general problem. If it is n prizes and n boys, then n to the power n, this is n to the power n minus n. So this one is general problem. And it is very simple problem. So number of ways of distributing the prizes without any restriction, n to the power r. But here no boy can get all the prizes. So you have to subtract r, number of boys, n to the power r minus r. Next, in how many ways three letters can be posted in 5 boxes? So 3 letters, L1, L2, L3. How many boxes? B1, B2, B3, B4, B5. So look, subject is letter to be posted. So first letter can be posted in 5 ways, second 5, third 5. So 5 into 5 into 5, 5 to the power 3. So number of possible ways. So if you use formula, then n to the power r. So 5 to the power 3. You should be cautious about n and r, not 3 to the power 5, because here letter to be posted. So use fundamental principle. 1, 2, 3, 4, 5. This is 5 to the power 3. So you should be cautious about value of n and r. Someone write this is 3 to the power 5. So 3 to the power 5. Then 3 to the power 5 if you write, then box would be brought to the letter. Then it will be 3 to the power 5. But this is not the feasible case. Feasible case is you have to post the letter. So this is 5 to the power 3. So today through these videos I have discussed some simple problems using permutation with repetitions. So you practice this type of problem from any textbook. Thank you for today.